Hello everyone, I'm Mahalakshmi, a third year student of Electronics and Communication Engineering from a National Engineering College, Kovilpatti. I'm here to present my internship project titled Home Automation Simulation, which I developed as a part of my training at Ematext Information Technology. This project is based on embedded C programming and IoT concepts simulated using Picsimlab. The main goal of the project is to design a system that can monitor and control home appliances automatically based on sensor input while also allowing the manual control through Blink IoT app. It combines both hardware simulation and software programming to create an efficient and intelligent home automation setup. During my internship, I gained extensive hands-on experience in embedded system and IoT application development. I learned how to program microcontroller using embedded C, how to interface peripherals such as sensors and displays, and how to simulate circuits using Picsimlab. I also explored IoT platforms like Blink, which enables remote control and monitoring through a smartphone. Additionally, I learned how to write efficient and modular code using real-time logic skills that are essential in modern embedded system design. This internship improved my understanding of both theoretical concept and practical system implementation. Introduction to IoT. The Internet of Things is a technology that connects physical devices to the internet for real-time data exchange and intelligent decision making. In a home automation system, IoT enables applications like fans, light, and water pumps to communicate through sensors and microcontrollers. In this project, the PIC microcontroller receiver input from various sensors such as the temperature sensor and the LDR process the data and sends control signals to output devices. The data is also shared with the Blink app, which acts as a remote interface for monitor and manual control. IoT thus provides connectivity, automation, and convenience by linking sensor, actuators, and users together seamlessly. This project heavily relies on embedded C programming to define all logical and control operations. I have used various concepts such as data types and modifiers to define variable size and ranges, decision making statements like if else, switch case to handle control logic, and loops like for and while to continuously read sensor data. Operators are used for arithmetic, logical, and bitwise operation, while functions help structure the code into smaller, reusable blocks for better readability. Pointers and arrays are used to manage memory efficiently, and preprocessor directors like hashtag define and hash include are used to include libraries and define constants. Through these C concepts, I was able to create a flexible, efficient, and responsive automation program. Keywords in C. In the C program languages, keywords are reserved words that have special meanings and purposes defined by the compiler. They are the part of the syntax of the language and cannot be used as a variable names, function names, or identifier. Each keyword performs a specific function and the compiler recognizes them automatically during program execution. For example, int, float, and char are used for declaring variable types. If else, switch are used for decision making. For, while, and do are used for looping. Other examples include auto, break, case, const, and continue. C contains around 32 keywords and they form the foundation of all the programs. Since they are predefined, the programmer cannot redefine or modify their meaning. These are also called reserved names because they are used is restricted for specific internal purpose of the compiler. The function printf and scanf are part of the C standard IO library declared in the stdio header file. Printf is used to display output on the console or screen. This prints the value of the variable temp in a formatted way. Scanf is used to read input from the user. Size of operator is a compile time operator used to determine the memory size in bytes of the data type or variable. It helps in writing portable code that can adapt to different system or processor. Modifiers in C. Modifiers are keywords that change the properties of the basic data type to control how data is stored, how much memory is used, and how large the range of values can be. There are two major types of modifiers: size modifiers, short, long, and long, long. They can change the storage size of integer data type. Sign modifiers, signed and unsigned. They define whether negative numbers are allowed. Decision making. In embedded system, decision making plays a key role in different system behavior. Then if statement executes a particular block when a condition is true. For example, turning on the cooler when the temperature exceeds 30 degrees Celsius. Then else if ladder checks multiple conditions sequentially and else handle all other cases. The switch case statement is used when several fixed options are available. It's more efficient than multiple if else condition. Looping in C helps the system perform repetitive operations automatically. For example, the for loop executes the task a fixed number of times, while the while loop runs continuously as long as the condition remains true. Then do while loop executes at least once before checking the condition, which is useful for reading sensor repeatedly. These decision and a looping structure together ensure continuous monitoring and timely response in automation. Arithmetic operations are used to perform all the basic mathematical operations on variables and constants. These include addition, adds two values; subtraction, subtract one value from another; multiplication, multiplies two values; divides, divide one value by another and gives the quotient; modules, gives the remainder of a division. Relational operators are used to compare two values or expression. They return their true or false depending on the condition. Examples include equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to. Logical operator. Logical operator are used to combine multiple conditions in a single statement. They are essential for creating complex decision making logic and returns true only if both conditions are true, or returns true if at least one condition is true, not reverses the logic state of a condition. Bitwise operator. Bitwise operator are used to perform operation at the binary level, directly manipulating individual bits of data. They are especially useful in embedded system and low-level hardware programming. Common bitwise operators include bitwise AND, bitwise OR, and bitwise XOR. One's complement, left shift, right shift. Ternary operator provides a short and compact from the if-else statement and it's written using the syntax condition expression if true or else expression if false. Assignment operator are used to perform assign values to variable. The basic operator is equal, but C also supports compound assignment operator for faster coding. Overflow and underflow. Overflow occurs when a value exceeds the maximum range that the variable can store. Underflow occurs when a value goes below the minimum limit of the data type. An array is a collection of elements of the same data type stored in contiguous memory allocation. Arrays helps organize large data sets of data such as multiple sensor readings or temperature values under a single variable name. The index of an array stores from 0, which means the first element is stored at index 0 and the second at 1 and so on. Array are useful in embedded system for storing data sequence, for example, storing multiple sensor values before displaying them on a CLC ID or sending them to the IoT app. Because array elements are stored continuously in memory, they can be easily accessed and manipulated using pointers, which makes processing efficient. Pointer in Cs. A pointer is a special variable that stores the memory address of another variable instead of storing data directly. Pointers are one of the most powerful features of C and are widely used in embedded C programming to access memory mapped register and peripheral devices. Indianness defines how bytes are arranged in a computer memory. This concept is crucial in embedded and system level programming because data storage order can affect communication between devices. Big Endian, the most significant byte, is stored at the lowest memory address. It's used mostly in older system and some network devices. Little Endian, the least significant byte is stored at the lowest memory address. It's used in most PC and controllers such as Intel and ARM based system. Null and while pointers. A null pointer is a pointer that points to nothing. It's intentionally assigned the value null to indicate that's not currently referencing valid memory. Functions. Functions are a way to divide a large program into smaller, reusable blocks of code. They improve modularity, readability, and maintainability. In your home automation project, for example, you might have separate functions for reading sensor, displaying data on CLCD, controlling devices, and sending information to the Blink app. This makes debugging easier and helps in code reuse. Parameters. Parameters are the variable listed in the function defines like a and b above. Arguments are the actual value passed to those parameters when the function is called. Call by reference. In call by reference, a pointer to the variable is passed to the function. Any changes made to the pointer inside the function directly affects the original variable. Auto local variable. An auto local variable is the default storage class for all local variables declared inside the function. It is created when the function starts and destroyed when the function ends. Register local variable. A register variable is stored to the CPU register instead of a RAM for fast access. It's used when a variable is accessed frequently, such as inside loop. Static local variable. A static variable inside a function retains its value even after the function ends. It is initialized only once and remembers its previous value in the next function call. Global variable is declared outside all the function, typically at the top of the program. It can be accessed and modified by any function in the same program. Recursive function is a function that calls itself directly or indirectly. Recursive is used to solve programs that can be divided into smaller similar subproblems such as factorial, Fibonacci, or searching algorithms. Const qualifier. The const keyword is used to declare read-only variables whose values cannot be modified after the initialization. This improves safety and prevent accidental overwriting of important data. Project overview. This project demonstrates how automation and IoT can work together to make daily home operations smarter and easier. It uses sensor to detect environmental parameters like temperature and light intensity and automatically controls home devices accordingly. The PAC microcontroller acts as the brain of the system, processing all inputs and triggering outputs. The Blink app serves as a user interface, allowing remote access to appliances through the internet. Overall, the project improves energy efficiency, reduces human effort, and ensuring comfort and safety through intelligent control. Block diagram. The block diagram explains the system structure clearly. It consists of sensor like LDR and temperature sensor which act as an input devices. These input are connected to the PIC microcontroller which processes the data and generates control signals for output devices such as LED, buzzer and the CLCD display. The Blink app is connected via IoT communication to allow user interaction and control. This setup demonstrates how hardware, software, and IoT integrate to form a complete smart home automation system. Peripherals used. The CLCD is used for real-time display of temperature, water level, and device status. The temperature sensor LM35 measures the surrounding temperature accurately and provides analog output. The LDR sensor detects light intensity and helps in controlling the LED brightness automatically. LEDs are used to indicate on and off status of applications and the buzzer provides audible alerts. The Blink app acts as the IoT interface for remote monitoring and control through the internet. CLCD. Character Liquid Crystal Display. The character LCD displays vital information such as current, temperature, water level, and system status. It operates in 4-bit mode for efficient data transfer. Whenever there is a change in a sensor readings or device states, the microcontroller immediately updates the display. The CLCD thus acts as a user-friendly interface, allowing easy monitoring of the system even without using the app. It also shows the HTR run or HTR off to indicate heater operation, improve transparency and usability. Buzzer. The buzzer plays an important role in the alerting the user about system events. It is connected to a digital output pin of the microcontroller and is activated based on certain condition. For example, it beeps when the temperature exceeds a limit, when the tank is empty or full, or when device are switched on and off. The buzzer enhances user awareness by giving immediate audio feedback, ensuring safety and prompt action in response to alert. Temperature sensor. The temperature sensor continuously monitors environmental temperature. It provides an analog signal proportional to the temperature, which the microcontroller converts into digital form using an ADC. When the temperature crosses a predefined threshold, the controller performs specific action, for example, turning off the heater and turning on the fan. The temperature values displayed on the CLCD updated. The temperature value is displayed on the CLCD and update in real time on the Blink app as well. This helps maintain an ideal environment while optimizing energy usage. LED. The LED serves as an indicator and output devices. It lights up when the connected appliances like bulb or motor is turned on and switch off when the applicant is inactive. The LDR sensor controls the LED automatically based on ambient light levels. It glows on darkness and turns off in bright light. This demonstrates smart lighting control using sensor based automation. LED make it easy to visualize device status and help verify program logic during simulation. When the system is powered on, the microcontroller initializes all the peripherals and sensor. It then starts reading data from the temperature and LDR sensor continuously. The CLCD displays real-time information such as current, temperature, and system status. Based on sensor values, the microcontroller automatically switches devices on or off. The Blink app allow the user to send manual commands and monitor live data remotely. The buzzer provides alert when certain limits are crossed. Overall, the system runs in continuous loop, updating readings and ensuring responsive automation. The three main software tools are used in this: Picsimlab for simulating the circuit with sensor and peripherals, MPLab for code writing, compiling and debugging in C, Blink app for IoT connectivity and remote control. This project gave me complete understanding of how embedded system and IoT work together. I learned how to write efficiency programs for real-time operation and how to simulate hardware connections and how to establish IoT communication. The project enhanced my practical knowledge in sensor interfacing, automatic logic, and embedded software development. It also improved my confidence in applying theoretical concepts to real world engineering applicants. So here's the demonstration part. This is the Arduino IDE user interface where I have written the code for home automation project. We create a separate file as they are easy to maintain, and we will look at one by one. First of all, this is the main file. It consists of the Blink authorization token device name and template ID, which we get when we register the device on Blink IoT cloud platform. And These are some preprocessor directory which we need to include in order to use Blink as well as the CLCT display. This is the function of the cooler pin which we display on the Blink IoT app in order to control the cooler. This is the code for heater pin. These are the code for inlet and outlet valve of the serial tank. We also need to display the temperature on the Blink IoT app. Hence, this is the code for the same where we display the real-time temperature reading. We need to handle the temperature about 25 degrees Celsius. We need to turn off. We also print the notification on the Blink app with the following code. We also need to control the water volume about 2000 liters. Hence, we create a function as handle tank. If the volume of the water less than 2000 liter, then it enables the inlet valve. If the tank is full, then the inlet valve is turned off. Now this is the setup function which called one time. We initialize idea, then the guidance light. We also initialize the CLCT display. We and print information on the, then we call the temperature system and it also initialize. Next is the loop function. Call this function return in it repeatedly moving on the next line. This is the garden lighter file. It consists of a function of initializing the garden lights and it also consists of function the brightness. When the brightness is tail, the LEDs are turned off and the brightness is low, and in evening and night time the brightness LED increases, and this is the LDR heater. So this is the LDR header file where we had defined some macros for the LDR sensor as well as the guard and light pin. This is the main header file. We also macros for inlet outlet pins, blink, terminal blink and temperature gauge. Next, the serial tank file consists of a function of initializing the serial tank. We define a volume function to get enable, disable and after 12 respectively. This is the serial tank header. Also macros for high float, low for volume to increase, enable and display. This is the file temperature system. We initialize the temperature system. We read the temperature from the temperature using this function. This is the cooler and heater. At last is the temperature header file where it consists macros for heater and cooler. So LDR system, these are the LDR garden lights. This is the Ethernet used for internet connection, the Arduino UNO board, and this is the temperature control. It has an inbuilt LM35. This is the cooler and it has a heater. And currently full and inflow is of the, this is the outflow. Next, I'll mirror my phone to the system. We will control this home as different home components using the mobile phone blink out here. So you can see now I have mirrored my phone in this. There are two tabs, tab 1 and tab 2 respectively. Tab 1 is for temperature system, tab 2 is for the inlet and outlet valve. The volume is displayed as you can see the current in 3000 liters. So first we will turn on the heater and check if the temperature is 35 degree Celsius. Whether the heater is turning on automatically or not, whether we have receiving the same for or not. So you can see the temperature is increasing So we receive the notification that the temperature is at above 35 degrees Celsius and turning off the heater. Now we'll turn on the cooler. When we turn on the cooler, the temperature decreases and the fan starts rotating and it tries to maintain the normal room temperature. We will turn on the cooler now. Next, we will check the cereal tank. So you can see that cereal tank currently it is full. Then in the flow is off. We will try to turn on the outflow and check if the level is then less than 2000 whether the outflow is on or off. You can see the outflow is on now. Notification for the same is displayed on CLCD. The water level is also decreasing, is less than 2000. The inlet valve is turned on automatically and it tries to maintain the water level. We will turn on the outlet and the inlet will now fill the tank when it reaches 3000 and it will turn off immediately automatically. So you can see inlet valve turn on automatically. It will check the notification. So you can see the water level is less than 2000 and this is the notification. When the tank is full, return off the inlet valve. So lights are off when it is nearly evening or light. Then the garden lights are brightest. That are this the light turned off on automatically.